Hi, everyone. Today, I'd like you to picture a meandering river. And most of you probably pictured something lush with vegetation, such as the Mississippi River or the Amazon River. And scientists actually used to think that this vegetation was required to have a meandering river. Meandering river geometry needs to have strong banks. So you need to have something to stabilize those banks. And scientists thought that plant roots were the only thing. However, if you look at that image on the right, those gray meander-like deposits are actually found on Mars. And so scientists began to look more at Earth's surface, and they began to find more meandering rivers that don't have vegetation, such as that river in green. Scientists think that the stabilizers of these rivers are likely clays or salts. However, scientists have not really looked into a more subtle biological component, which is EPS. EPS stands for extracellular polymeric substance, and it's a sticky substance found everywhere here on Earth created by common microorganisms. On the left, you can see that EPS can hold sand grains together. And in the center image, this is an experiment where 1% of EPS added completely stopped sediment transport when water was run over the surface of the sand. The problem is that this central experiment used xanthan gum. So it was not a true EPS. It was not created by microbes. And many of the field experiments were looking at temperate, wet environments, which are not good Mars analogs. So I propose to do a broad survey of Mars analog environments to extract EPS and to look at grain size and mineralogy, because I hypothesize that drier environments will actually preserve EPS better, that the iron oxides and clays will actually cause the EPS to have more cohesive strength, and that these smaller grain sizes in depositional environments will protect the EPS as well. If this is true, this may change the way that we search for life on Mars and other planets. But even if it's not true, this could still have huge implications for how we study the history of Earth, how we understand restoration here on Earth, and how we think about sediment processes here on Earth and other planets.